Welcome students. Today we will cover potential at a point due to electric dipole. Means at any point. It may be axial, it may be equatorial. Like the previous chapter you can find out along axial and equatorial how to find out. Now I will tell you for any point how to find out. Let us check. Draw a dipole first. Try to draw the bigger one. Let it have two charges at point A and B. That is, one is minus Q, another one is plus Q charge. This is the center point, obviously separated by 2L distance. Let at any point, let us take, let this is the point. Potential formula is very easy formula, KQ by R. Easily we can find out. So what are you thinking that? So there are two charges. Let distance is R1, let this distance is R2. So what will be the net potential? Let us check it first. So potential at P, let us write down here. Potential at P is equal to potential at P due to A plus potential at P due to B. Easy one. But the problem is what? That means I can write this is nothing but equal to, for each case, 1 by 4 pi epsilon naught will be there. KQ by R. Here Q is minus Q for A, minus Q by R1. Similarly plus 1 by 4 pi epsilon naught plus Q by R. So 1 by 4 pi epsilon naught is common. I can take Q also common. And this will be due to B. So the distance is R2. Let me simplify it, 1 by R2 minus 1 by R1. Let us mark it here. What is R1? AP. R2 is BP. Something we have to draw here. If I want to draw properly, let us draw it. Different methods are there. You can follow any method. Now in this case what I want to do, to draw the perpendicular from A to OP line. When I am drawing this perpendicular, that means this is the perpendicular. Let this point is C. From the figure, AP will be equal to CP when distance is at a very far large distance comparing to the dipole length. Let this distance is R. Then what can I tell? This distance equal to this distance. That means my task is to find out R1. What is the R1? R plus this distance. Don't confuse that, sir. How can I tell these two are equal? This is 90 degree. For a large distance, it is considered these two sides are equal. Comparing to this length L, the practically which is a very millimeter, distance, to meter distance is a large. So for a very large distance case I am telling for which case r is okay. Now who is this distance? This is the angle theta, that means this is also theta, this was L. So if this is theta, this is 90, we know L, we know theta. I want to know this distance, I want to know CO, this distance. So what is CO from this figure? For this theta, this is base, so I can write here cos theta. So this is base, this is h, cos theta equal to what? CO by L. For my case I need CO, CO is nothing but equal to now L cos theta. That means from this case I can write, very simple thing I can write, what is that? R1, which is nothing but equal to AP, which is nearly nothing but equal to CP, is equal to R plus L cos theta. That means R1 is R plus L cos theta. Is it clear now? My question is, similarly I need to find out R2. Obviously comparing to R, R2 is smaller. Let us draw a perpendicular here. So this is perpendicular. Let us mark this point as D. Now from this triangle, which triangle? Okay, this was from the triangle ACO. Now I want to check the triangle DOB triangle. Why I want to find? Obviously this thing will be equal to this thing. BP will be equal to DP. I want R2. R2 will be nothing but R minus this component. R minus this component. That means R minus OR. Now how to find out? Look at here carefully. From this triangle, this is theta. I want to know this base. That means cos theta. So what is cos theta? B by H. B is my extra distance. DO by L. This is L. So from here what I got, DO, the extra distance, is L cos theta. Now from the figure, PB, that is nothing but R2 is nothing but PB, which is nearly equal to what? DP. So what is DP? OP minus OD. Or what can I write? I can write R2 is nothing but equal to OP. What is OP? R. OD. What is OD here? L cos theta. So I got 2A and 2B. This is for R1, this is for R2, will be applied here. Now the question is, I got R1, I got R2. So from equation 1 and 2 I can place this value here. How can I place? Okay. Let us mark it 1A, let us mark it 1B, 1, 2. So from equation 1 and 2, by putting the values of R1 and R2 in equation 2, what will be the net potential? The net potential Q by 4 pi epsilon naught will be common. 1 by R2. 1 by R2 means 1 by R minus L cos theta. 1 by R1. 1 by R plus L cos theta. Now we know the math. You can proceed and solve it. R minus L cos theta into r plus L cos theta. So here it will be r minus L cos theta minus r plus L cos theta. So from here r will be cancelled and I will get, this will be minus, so minus 2L cos theta. Little bit mistakes I have done. In this case it will be r plus L cos theta, and in this case it will be r minus. So here r plus L will be multiplied, here r plus L will be multiplied. So minus minus will become plus, so this will be 2L cos theta. So I will get it here, q by 4 pi epsilon naught 2L cos theta by, this is a plus b into a minus b, a square minus b square formula, r square minus L square cos square theta. And as we know, 2Lq, yes, you are right, that is electric dipole moment. Let me write it here. Since 2Lq is electric dipole moment, potential is scalar, no need to focus it. 12 is the dipole length, q. So I can write it here, p cos theta by 4 pi epsilon naught. I will write here r square. Why? R is very, comparing to L, it is a very, very large quantity. So r minus L square cos theta will be tends to r square. Like 1 crore minus 1 paisa. Like that comparison. So this is my net potential at any point due to electric dipole. Another formulas in books written, I can write it here, p cos theta by 4 pi epsilon naught. I will multiply r, divide r. Divide r means it will become rq. And ab cos theta. What is ab cos theta? A dot b. So p dot r 4 pi epsilon naught rq. So this is also the formula they are using. Now directly from here, can I find axial and equatorial? Yes. How can I find? Suppose I am telling for axial cases. I am going for case 1. What is the case 1? That is nothing but axial, the point lies on axial lines. Okay. If the point lies on axial line, let us look to the figure. That means point will lie here. That means theta will be totally, this line will totally merge with AB. Theta will be 0. If theta is equal to 0, then what will happen? Then Vp will become, what is the formula? 1 by 4 pi epsilon naught p cos theta by 4 pi epsilon naught r square. Let me write it. P cos theta means p cos 0 by 4 pi epsilon naught r square. Cos 0 is 1. So it will be, due to axial case, it will be p by 4 pi epsilon naught r square. If I go for case 2, equatorial line, when point lies on equatorial line. What is the equatorial line? This case when we have like equatorial axis. That means at that case theta is 90. That means I will write for this special cases theta is 90. That means cos 90 is 0. So if I put that formula here, potential will be 0. That means at any point, suppose this is my equatorial line, at any point on that equatorial line, potential is 0. And if potential difference between any point is 0 means that is equipotential. So this line is equipotential line. Similarly, lots of applications are there. We will see it. Thank you.